Hi class, this is Dr. Karsten, and today we are doing lesson 15 from module 5, grade 4 of Engage New York Math. And today's lesson is very similar to yesterday's lesson. In yesterday's lesson, we were looking for basically common numerators or common denominators to help us compare two different fractions. In today's lesson, we are again going to be comparing two different fractions, and this time we want to find common units or number of units to compare the two fractions again, which just basically means to find common denominators or numerators. We're really going to be focusing in on the denominators, and this time we are going to be having unrelated denominators. So in yesterday's lesson, for example, we may have had, let's say, 1/5 and, 3/10, and we wanted to compare them. And 5 and 10 are related because 5 times 10 was 2. Today, that is not going to be the case. Today, our denominators will not be related, and we're going to have to find a way to compare them anyway. So there's going to be two ways that we're going to do it. The first is using an area model, the other is multiplication. I am going to do the area model for just one of these problems because I really want to focus in on the multiplication because knowing you guys, my students, I think that that's the one that's going to work for you the most. But I do want you to see why it works. And so we are going to do the area model for one of these. So let's go ahead and start off. So let's say that I wanted to compare 3/4 and 4/5. So if I want to compare these two fractions, what I can do is I can draw an area model for each of these. We're going to draw the area models slightly differently from each other. So for 3/4, clearly my denominator is 4, so I need to divide or partition the whole thing into 4 pieces. So let me start by drawing two area models that are relatively the same size. We're human, so they're not going to be perfect, but that's close enough for what we're doing. Okay, so I'm going to divide this into 4 pieces, this first one, because I have fourths. So let me do the best I can to try and make them even. And then since my numerator is 3, I have to shade in 3 of those fourths. So my numerator is 3, I'm going to shade in 3 of them. So I'm going to do my best to try and shade these 3 in nicely for us to work with. Okay, so now let's go ahead and let's do 4/5. So since my denominator is 5, I need to have this partitioned off or divided up or split into 5 sections. So in this case, I'm going to do it horizontally to do it a little differently, and you'll see why in a sec. Okay, so our denominator told us that we needed 5 sections, and now I'm going to shade in 4 because our numerator tells us that we have 4 of them. So I'm going to shade in 4 of these sections. So right now, comparing these wouldn't really work. I really don't have, they're not equal denominators. We don't have, we don't have common denominators, we don't have common numerators, and these are unrelated. There's really not an easy way for me to look at these and know which one is larger, which one's smaller. Unless, of course, some of you might be saying, well, Dr. Karsten, I know that fourths are bigger than fifths, and this is 1/4 away from 1, and this is 1/5 away from 1. And then I would say, you get a bonus point. But let's pretend that we couldn't see that. Let's say that we were looking at this and we did not see that relationship between these two. So what could we do instead? Well, watch what I'm going to do. I'm going to go ahead and I'm going to take each one of these fourths and I'm going to divide it or split it up into 5 pieces. I'm going to decompose it into 5 pieces. I'm going to use dotted lines for this just so that we can tell which were our original lines and which are our new lines. Oh, that was a horrible one. I apologize. Okay, and now what I can see is that I have a total of 20 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, of which 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 are shaded. So now what I know is that 3/4 and 15/20, those are equivalent fractions. They have the same value. I didn't shade or erase anything. Everything is the same. So now let's do the same thing over here, but what I'm going to do is I'm going to take each one of those fifths and I'm going to decompose it. I'm going to turn it into 4 pieces. So if you look at this, again, I have 20 pieces, or 20 parts, or 20 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And in this case, I have 4, 8, 12, 16 that are shaded. So now that I have denominators that are the same, that are common, 20, 20, I can now compare those numerators. And what I can see is that 16 is larger than 15. There's more pieces, which means that 4/5 was larger than 3/4, or 3/4 is smaller than 4/5. Okay, so this is great if you can see what you need to do. Did you guys actually notice what we did here? What do you think we could do mathematically? Just think about that for a sec. I'm kind of curious if anyone realized that when we were decomposing, we could have actually just done a multiplication sentence for each of these. Let's try that. Let's take 3/4. And what we did was we decomposed it, so we multiplied. Remember, when you decompose, you make more pieces, but each piece is smaller. So here's our original fraction. And then what we did was we decomposed it by multiplying by 5/5, right? All four of those guys got multiplied by 5, or split up into 5 pieces, decomposed into 5 pieces, as did the 3 in the numerator, the 3 shaded. And what we ended up with was 3 times 5 is 15, and 4 times 5 is 20. Let's try this one and see what we did. So we started with 4/5, and then we decomposed it. And the way that we decomposed it was by multiplying both by 4. And when I do that, I get 4 times 4 is 16, and 5 times 4 is 20. So again, now 4/5 and 16/20 are equivalent fractions. I don't know if you're noticing this, but look, we multiplied by 5 here, and over here we multiplied by 4. Do you know why we chose to do that? Because we simply did a nice, easy way of doing this, which is we multiplied by the other denominator. So when we had 3/4, we multiplied it by this denominator, 5. You can see that down here. And for 4/5, we multiplied it by the other's denominator, the other fraction's denominator, which was a 4. So we're multiplying by the other fraction's denominator to get us a common denominator. Basically, look at your two denominators, 4 and 5. You want to be multiplying those numbers. So 4 times 5, or 5 times 4, and whatever you do to the denominator, you do to the numerator. And that's all we did down here. So instead of doing a whole bunch of problems on this paper, I'm actually going to jump us right into the problem set. And the reason for that is that I do want to focus on the multiplication aspect of this and less on the area model part, because I think that's just going to confuse a lot of us. So I think that it would just be smarter for us to focus on doing the multiplication. So that's my goal today. And what I'm going to do is I'm going to do a couple of the ones on this page doing multiplication. And then your work is going to be to do this page. And I'm actually going to do 1 or 2 on this page too for you, just to help you out. So let's do like 1 or 2 over here, and then we'll go to the next page. So this is actually a pretty easy thing that we're going to be doing. So let's take a look at this. So let me see if I can kind of zoom in a little for us. Pretty good. Okay. So here it says we're comparing 3/5 and 4/7. Again, I don't see common numerators, I don't see common denominators, and I don't see related numerators or denominators. So given that, what I'm going to do is I'm going to be multiplying 5 and 7. So I'm going to multiply 3/5 by the other denominator, so 7 over 7. And I'm going to be multiplying 4/7 by the other fraction's denominator, which is 5. So let's go ahead and do that. So I'm going to take 3/5, and I'm going to show taking 3/5 and multiplying it by the other denominator, which was 7. Whatever I do on the bottom, I do on the top. And then I get 3 times 7 is 21, and I get 5 times 7 is 35. So now let's go ahead and do the same thing for 4/7. So I'm going to first show what I'm starting with. I'm decomposing, so I'm multiplying. And now I'm going to multiply by the other fraction's denominator, which is 5. So I put a 5 in the denominator, a 5 in the numerator, because that just makes 1. 5 over 5 is 1. Multiplying by 1 does not change the value. It's going to give us an equivalent fraction. Okay, so 4 times 5 is 20, and 7 times 5 is 35. So now you can see I have 30/5 for both of these, but now it's super easy to see that 21 is larger than 20. So here the sizes of the pieces are the same. They're both 30/5. Remember, this is just a label for the size of the pieces. But this is the number of pieces. So if my sized pieces, if my pieces are the same size, having more of them will definitely be more. So 3/5 is going to be larger than 4/7. And that's what we wrote. So let's do another one right here. And I think that you guys are probably getting a pretty good handle on this nice little shortcut that we're doing here. So let's compare 3/7 and 2/6. And again, I can see that my trick here, well first, my numerators don't match, my denominators don't match, and they're not related. Right? If I took 2 and I did multiples of 2, I would never get a 3. And if I did multiples of 6, I would never get a 7. So what we're going to do is we're going to start with 3/7, and then we're going to decompose that. And we're going to do that by multiplying by the other denominator, 6. But again, whatever we do in the denominator, we do in the numerator. And then we get 3 times 6 is 18, and 7 times 6 is 42. So now let's do the same thing with 2/6. So 2/6, what I'm going to do is I'm going to decompose it. So first I write the original fraction, and then let's see, I'm going to multiply by the other denominator, and the other denominator is 7. So I'm going to do times 7 over 7. So 2 times 7 is 14, and 6 times 7 is again 42. Now I have a common denominator, so I know all my pieces are the same exact size. But for this one, I can see that 18 is larger than 14, which means that 3/7 is larger than 2/6. And we can just write it in. Okay, I feel like you're probably getting a handle on this. So I want to show you a problem on this page. So this is the next. So this is problem set. We're still in problem set for lesson 15. This is problem 2, and here they're basically saying that we can solve these. It says, rename the fractions as needed using multiplication in order to compare each pair of fractions by writing, and then we can write our symbols. So let's jump right into this. And what I'm going to do is I'm actually going to help you out with, I'm going to let you do A all by yourself. I want to take a look at C with you, actually. So let's take a look at C. Here we have fractions greater than 1, and part of this is that we could actually just pull out the 1 and then work with it, but I really feel like I want to stick with the one thing that we are doing. So I'm going to stick with it, and I'm just going to do the multiplication. So here we have 7/5, I have 10/8, the numerators are not related, the denominators are not related, they're not the same, they're not related, so I'm going to go ahead and use that trick where I can multiply the two denominators. So I'm going to multiply by the other fraction's denominator. So let's start with 7/5. And 7/5 is the number we're starting with. So we're going to multiply the top and the bottom. And we're going to multiply both of them by the other's denominator. So the other fraction's denominator was 8. So we're going to multiply by 8 over 8, which is just 1. So 7 times 8 is 56. And 5 times 8 is 40. So now let's do 10/8. So again, I'm going to show what I'm starting with, and I'm going to multiply by the other fraction's denominator, which in this case is 5. 10 times 5 is 50, and 8 times 5 is 40. So now what you should be seeing is that very clearly 7/5, 56/40 is greater than 50/40, which means that that is larger also. Wow, I feel like they're all going the same direction, all the ones that I've picked to do for you. How funny is that? So let me go ahead and let me do one more with you, and then I will tell you what your assignment is for today. And remember, you don't have to jump right into this. Remember that you might have one that is an easier problem to work with by using one of the other techniques that we've been working with. So for example, I want to show you one that might be true for, which is problem D. So now let me say this. In number 3, it says use any method to compare the fractions. Record your answer using greater than, less than, or equal to. So if I want to do that, I'm going to go ahead and I'm going to take a look at D. So for problem D, instead of, I'm looking at this and I'm saying, well, I have a choice. Actually, you could do it either way. Sorry, I'm just thinking for a second. This will work. So I'm going to go back to doing something a little different, which is I'm going to take my 8/5 and I'm going to pull out a whole from that, just to remind you how to do this. So if I have 8/5, can't I say that 5/5 is one whole? And remember, this is just the size of the pieces. It's naming it. So I have 8 of these pieces. Over here I put 5 of them, which leaves me 3 of them. So 8 minus 5 is 3. Now let's do the same thing with this, 9/6. But in this case, I'm pulling out a 6/6, which is one whole. So if I have 9 of this size pieces and I put 6 here, that leaves me 3 of them over here. Now what I can do is I can say, well, the 5/5 and the 6/6, those are both just 1. So I can kind of ignore them for a second and just compare the fractions. And if I have 3/5 and 3/6, I have a common numerator. So I can say, well, which denominator gives me bigger pieces? This gives me bigger pieces. So since this one gives me bigger pieces, I now know that that is going to be the larger fraction, because it's going to be 1 and 3/5 versus 1 and 3/6. And then I can go ahead and I can write that up there as well. Now again, I could have just done the multiplication. Let's do that too. So we're going to take that first fraction, 8/5, and I'm going to multiply 8/5 times the denominator of the other fraction. And I'm going to get 30 on the bottom in the denominator, and then 8 times 6 is 48. And let's do the same thing for 9/6. Only for this one, I'm now going to multiply by the other denominator, which is 5. So 9/6 times 5/5 gives me 45/30. And now I can see again that 48 is larger than 45. So that's what we wrote there. We said that 8/5 would be larger. Okay, I'm going to do one more with you. Let's go ahead and I'll do this first one with you, and then you guys are going to, for homework, do 5 problems on your own. Okay, so let's do this one. We're going to use the multiplication rule that we've been doing, and this is the last one again. So 3/5, because again, I don't have common numerators or denominators. They're not related. So I'm going to show what my original fraction is, which is 3/5. And then I'm going to multiply by the other denominator, which is 6. So 3 times 6 is 18, 5 times 6 is 30. So I have 18/30, and I know 18/30 is equivalent to 3/5. Now let's do the same thing for 5/6, this fraction. So I'm going to show what I'm starting with, 5/6. I'm going to decompose it by multiplying it by the other fraction's denominator, which is 5. And then I have 5 times 5 is 25. 6 times 5 is 30. And now I can compare. So again, 5/6 is equivalent to 25/30. So now I can compare these two because they have denominators that are the same, they're common. So each piece is going to be the same size, or each part, or each unit, fractional unit I should say. And here I have 18 of them, and there I have 25. So clearly, if all the slices of cake are the same size, having 25 of them is going to be a lot more than having 18 of them. And so I'm going to show that right there by saying that 3/5 is less than 5/6. And I know that from doing this, from working it through. So that's it, class. This is like a super quick lesson, and I did a ton of examples. So, again, what we are doing is we are multiplying by the other fraction's denominator to come up with a denominator for both the fractions that matches. We're basically finding a common denominator by using multiplication. Okay, so if you have any questions, you can ask me tomorrow morning in our Google Meet or in our Google Classroom. And otherwise, I hope you have a great night. I'm going to go and load this up for you, and I will see you bright and early tomorrow morning. Have a great night.